it could just be a flat square with 0 height, and each side is square root 108. Make sense? That's the limit of how big x could possibly be. If x is any bigger than that, the surface area is going to exceed 108. And so that's why the feasible domain of this question is x can't be less than 0, but x also can't be greater than 108. Make sense? And so basically we're translating this physical question into this algebraic question that we already know how to solve, right? We already know how to figure out how to maximize a function on an interval. We've done that question quite a few times already. And so that's where this concept of feasible domain comes into play in these questions. So let me continue. Any questions about that, though? Questions? Okay. I will continue. So as you guys remember, finding the absolute maximum or absolute minimum of a function on a domain or on an interval, we have to first find the critical values, and then we're going to test each one of those critical values along with both of the endpoints. I think you guys remember this. So to find the critical numbers, we're going to take the derivative first. The derivative is going to be 27 minus 3/4 x squared. I think we can agree on that. And we're trying to figure out where this derivative equals 0, right? That's going to tell us the critical numbers. So that means we're trying to solve this equation. 3/4 x squared equals 27, which means that x squared equals 36, x equals positive 6, right? Can't be negative because we have this interval that we care about, right? Questions?
We take the derivative here.
We're trying to find the critical numbers because we're trying to maximize the function.
So maximize like.
We're trying to maximize this function here.
Yeah, and the function, that's the simplified whatever version of the box. Right, and so.
Yep. We're trying to, this is the volume.
We're solving for how many.
Yeah, we're solving for the value of x that will maximize f of x, which corresponds to the volume of the box.
Yeah, that's x is the volume of the box.
Yes.
Well, which is your function that maximizes? What is maximizing? Just maximizing the space that you can use.
This function literally gives us the volume of the box, so we're trying to maximize this function.
Okay.
Yeah. Okay, so our critical number is x equals 6. And so that tells us that we want to test 3 different points. We want to test 0, 6, and square root 108. Because those are our two endpoints in our one critical number.
One question.
Yeah, Daniel.
So why did you just got rid of the negatives because they're both negative on both sides for the 3 over 4x squared equals 27?
What do you mean I got rid of the negative?
On the first line where you f derivative of x, yeah, that to that, wouldn't it just be negative 3 over 4x squared equal to negative 27? So you just get rid
Sure.
of the negatives on both sides?
That's fine.
Is that what you did?
Yeah. Okay, so I'm going to now find the volume of the box at each of those points. So f of 0 is going to equal 0. F of 6 equals, I don't know, what is it equal to? 27 times 6 minus 216 divided by 4. There's a calculator.
What'd you go?
27 times 6 minus 1/4 times 216. Wow, interesting. It equals 108. That's weird. Anyways, and then thirdly, the volume at the end point, at the other end point, is going to be, I think it's 0. Okay, so that tells us that x equals 6 maximizes the value of the function. Maximizes f of
You
x.
use the critical numbers. You use the critical numbers. And where do you get the 6?
X is the critical number.
I did not have enough.
6.
This is really confusing.
Oh, sorry.
Are you gonna take points?
Maybe. I'm just kidding. Okay.
Okay, wait. So let me get this straight.
So x equals 6 maximizes the volume, and then we want to find the other dimension, right? We want to find h as well. So we're going to go back to our previous equation for h, and we're going to plug in 6. And that is going to give us 72 minus divided by 24. It's going to give us 3. Okay, so this would be our answer. X equals 6 and h equals 3. Any questions? So let me go over all the steps for the question, just so it's clear. Our first step is we want to, the textbook calls it a primary equation. So that was the equation for the surface area, right? That tells us how the variables in our equation are related to each other. And then secondly, we want to write the function that we're trying to maximize. In this case, we're trying to maximize the volume, right? That we're trying to optimize. That's a better word. So in this case, we're trying to maximize the function f of x, which corresponds to the volume of the function. Then third, we want to determine the feasible domain for our variable. Okay, you guys want to be quiet?
Mr. Knight, try these strawberries because I don't know off the side of the room.
And then fourth, we want to optimize the function on that domain.
And steps for operation.
Huh?
Is that steps of operation?
I don't know what you're saying.
Like 1, 2, 3, 4. Like steps of operation.
Yeah, that's how you do the question.
That's what I'm saying.
1, 2, 3, 4. Yeah. Any other questions?
Classwork now?
No, I have 2 more questions to go over.
Are they all the classwork?
Let's do number 2. Number 2, it says 4 feet of wire. I made a typo. 4 feet of wire are to be used to form a square in a circle. How much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area? I'll remind you guys to put away your electronics.
Chat GPT the homework again.
Okay, so we're going to start by writing the equation. So it would help to have a variable, right? So let's draw it. We're going to form a square and also a circle.
Is this number 2 on the class?
It's number 2 on the classwork. So let's call, what should we do? Let us call, what should we do? I actually don't know. Let's say that x is the side length of the square and r is the radius of the circle. So at this first step, there's a lot of freedom in terms of how you define the variables. So you can pretty much do whatever you want. Okay, so our constraint is that we know that 4 feet of wire are to be used in total, which tells us that 4x plus 2 pi r equals 4. Make sense? Because 4x is the perimeter of the square, and 2 pi r is the perimeter of the circle. So that's the amount of wire that's being used in total.
Dude, what's the 4x again?
There's 4 sides of the square.
Yep, so the perimeter is 4x. All right. And then what are we trying to maximize? We're trying to maximize the total area. So we're trying to maximize f of x equals x squared plus pi r squared. Okay.
I take the derivative of that, 2x plus.
Well, the problem is we still have two variables, right? So we want to get everything into one variable first. So that's an important step. What would make this easiest? Let's write r in terms of x. I think that's actually not as easy, but... So let's try to write r in terms of x. So we're going to isolate r. We're going to do 2 pi r equals 4 minus 4x. R equals 1 over 2 pi times 4 minus 4x.
Wait, slow down. What?
4x plus 2 pi r.
Don't you just put it under?
I'm not too sure what you're saying.
So when you have the 2 pi r, you want to...
Yeah, I multiplied by 1 over 2 pi. That's the same as dividing by 2 pi, right?
Can we just rewrite that?
Sure. Yeah. Okay. I'm not going to fix it. This is clear. Yeah. Sorry. And then just to make my expansion easier, I'm going to factor out the 4 as well, which will give me 2 over pi times 1 minus x. Okay? And then I'm going to try to write my function in terms of only one variable. So only in terms of x. So I'm going to plug in my equation for r here back into my function. So that's going to be f of x equals x squared plus pi times r squared. But r squared is just 2 squared over pi squared times 1 minus x squared. And if I keep simplifying this, you guys all know how to do this, so I'm going to do it quickly. I'm going to get this.
So we rewrite it and plug it back into itself.
No, we're trying to get it in terms of one variable.
So we're breaking it. So we're breaking it down to like 2 parts. And then
Yeah.
it's a pot. Oh, okay.
The algebra looks confusing. You guys would be able to figure out on your
No,
own.
this makes
Okay,
sense.
but just try to understand the overall strategy of what we're trying to do, right?
This would be on the test.
Yes,
Because you're isolating each variable and then you're plugging it back in so that you have it in terms of itself so you can solve.
sure, yeah.
Yeah, like solving by replacement.
Now what do we try to do? We try to find the feasible domain, right? That's my third step. Determine the feasible domain for our variable. So like, think about it. What is the least that x could possibly be? Please, somebody tell me. 0? What's the maximum it could possibly be?
0 a little bit.
What?
0.
I said the maximum.
Oh, the maximum, it could be 4. 4. Square root of 4. 2.
It's a pi squared.
You're just guessing all the numbers.
Did somebody say it?
2 pi?
Pi squared.
I'm not hearing any correct answers. It's 1, right? The maximum possible for x is 1.
We are the only people talking in this class right now.
Okay, I'm sure some of them said it. I just couldn't
Why does
hear
it
it.
help?
Okay, the reason why it's 1. The reason why it's 1 is because otherwise the wire used would exceed 4 feet, right? Okay.
Of course.
Because wait, the perimeter.
Okay, I don't know if you're mocking me, but
The
Wait,
perimeter.
but where it is that it can't exceed 4 feet.
I mean we're only using 4 feet of wire, right?
Oh, I didn't
Yeah,
see
and
that. I'm sorry.
So the feasible domain for x is 0, 1. So we're restricted to within that domain. So we're trying to find the, maximum of f of x within this domain of 0, 1.
Wait, but you could have done that without doing any math.
What?
Like, couldn't you have just figured that out without?
The feasible domain?
Yeah.
Yeah.
Oh.
Yeah, but no, you use that equation to get the. You have to take
Yeah,
the
Rede?
derivative of that equation so you get
Rede?
critical numbers and you use all of them. These two and critical
Huh?
numbers. And plug them back in to figure out which one is the maximize.
Can I just work with him on the test?
No. All right, let me continue.
Wait, can you go back?
Now we're trying to find the critical numbers for f of x. So we'll take the derivative. If you take the derivative, this becomes, right? You know, this would be easier if you guys just stopped talking. Anyways,
Yeah.
Can you go up one line?
okay, I can't keep doing this. Just write as fast as possible.
Hey, it's okay.
Okay, so I took the derivative of f of x, and now I'm going to try to solve for x. Okay. Okay, so that's my critical number for x. Any questions?
Do the plugging now.
Yes, Vincent?
Can you walk through how to get the domain?
Sure. 0 is the minimum possible for x because you can't have a square with negative side, right? 1 is the maximum because otherwise we would exceed four feet of wire.
That makes sense. I was just wondering because is the equation asking for 4 feet total of a square and a circle?
Yes, 4 feet for both the square and the circle. Yes.
So does that mean 4 feet for using whatever combination of the amount of wire for a square and a circle to total to 4?
Yes.
So then, how do we find the limit
No, there's a limited
of
section.
used for the wire using only the limit of the square?
Because if the square has perimeter 4 feet, that just means there's no circle. Okay? So I'll continue. You can basically figure out that this is the maximum. I don't know why the numbers are so annoying. So the maximum is if the square has this side length and r equals, where is r? R is 2 pi over 1 minus x. 2 over pi times 1 minus x. And so I'm going to plug in my value for x into my equation for r. Okay. So once you plug that in and simplify it, you'll find that the side length of the square is 8 over 2 pi plus 8, and the radius of the circle is 2 over pi plus 4. And this will maximize the total area of both the square plus the circle. Okay. Any questions?
Did you do the integral testing, domain integral testing?
I did not. I should have, but it would have taken me too long.
Okay.
Let me just let you guys try some and not do the third one today. I'm a little worried. Yeah. So how about you guys try number 4? That's not too hard. And number 5 is also not too hard. So, yeah. And let's forget about 3 and 6. I'm worried I will lose you guys on those. For today. If we have time, we'll do it. Yeah.